talking about this CVI, Chrysler CVIs are, remember what CVIs are, clutch volume index. We're going to tinker with them a little bit, but mostly I'm just going to talk about this kind of an interesting transmission. Now, these transmissions are all over the place. Now, I wouldn't have any real point to teach you about a transmission if wasn't none of them out there. You know, but these things are in PT Cruisers and Dodge Caravans and all kinds of stuff. Now this 401TE, the solenoids on the one that you were, talking about earlier, and also you had the that Ford transmission that you had that had the solenoids on the end of the valve body and then that lead frame plugged into them and all that kind of stuff. They were inside the transmission, and they were kind of like this right here. See, them solenoids are made on the valve body. Most of them have them on the valve. Or there'll be a solenoid pack that has all the solenoids in it, or they'll have them on the valve body separately where you can change them out. But this transmission here, their solenoids are all right there in that little pack. And I think I got one of these over here. This is what they look like. Right here. That's a solenoid pack. Real simple, all together. Buy them at parts house and places. But anyway, they're right there. All right, and so the solenoids right there separately, and they're kind of expensive. If you buy all of the solenoids for like a '98 Ford Taurus, you'll pay several $100s for a whole set of solenoids, unless you buy them from a trick deal price person. Now, a solenoid basically works like this. Whenever the solenoid is not energized, this little ball is lifted off of its seat right here. It's just sitting there. Spring pressure is holding it off the seat. And the pressure that's coming into that solenoid is dumped back out into the sump. It is dumped. Now, there's no clutch receiving any pressure right here. It's like it's an electronic leak that's made on that. Well, whenever the solenoid's on, you notice this moves down and it closes that off. It squeezes that spring, closes that off so that it can't get to that dump, and then the pressure goes on through, and that applies it'll move a shift valve, or it'll apply the clutch or something like that. Pretty much how solenoids work. It's just a basic look. This is the winding, the engine controller. One of the ways the engine controller checks the solenoids is if it doesn't have the solenoid energized. There's voltage coming in on the other side on the solenoids, like the ones that you've been familiar with. On the Nissans and stuff, they're basically hardwired to ground. The Japanese transmissions, they like to hardwire them to ground and shoot power to operate the solenoids, but the American transmissions, for the most part, will have them hardwired to power, and the PCM will ground them. And it's a little less traumatic to break a ground side of a circuit than it is to break a hot side of a circuit. You get less disturbance and everything else that way. All right, so this is a little solenoid pack, just like I showed you a while ago, holding up there. It's pretty easy to replace and a lot simpler to get than most solenoid packs. They also got a couple of speed sensors here, and I'll talk about those again in a minute. And there's your neutral safety switch down there. That is one thing on this one, that you got to pull the valve body to to replace the neutral safety switch on this one. But look, this is Robert Austin Davis over here working on that Ford transmission. The solenoid pack, that one that's got that lead frame, which also doubles as a transmission controller. But this thing right here is like on the E40D or 4100, the transmission, I guess it is. But that solenoid pack goes up, and this comes through the transmission housing with an O-ring, and then you plug your wires into it. So that's what the solenoid pack looks like on that. Now, on other transmissions with single solenoids, have got solenoids you can change out here. You see these little shift valves? Now that is the manual valve right there. That's the one that's hooked to your gear selector where you go PRNDL. There's one guy wanted to put a shift kit in his Chevrolet. And while he had it out, he managed to drop the valve body or something, and I'm surprised he didn't damage it more, but he bent this. You can't straighten that out. I got it in there on my desk. You can roll it. You know how when you're playing pool, how you roll a pool cue to see if it's straight before you shoot you can roll that thing and it just flops around all over the place. You couldn't play pool without one. But anyway, here is the solenoid way there. It's got a little retainer you pull off and all that. Incidentally, when you're cleaning a valve body, some of these valves right here, if the valves are steel, you can grab them with a magnet and work them out of there. But on some of these those old transmissions that they used to have in the older Rangers and Bronco 2s that I used to work on back in the 80s, those dadgum things are all aluminum. They take you a full day to clean a valve body. It's aggravating, it's darn thing, everything. The transmission mechanic just throw a valve body on it whenever he did one, so he doesn't clean them, But any little particle of trash that gets in there will cause the valve to stick, and you'll have issues from that if you're not going to clean. But anyway, the 4TE solenoid pack, you can actually buy kits online. They come with both of the speed sensors, which are right here, easy to change. They're just plastic thing. And this solenoid pack, which you just got to pay attention to what you're doing when you change it out. And you can get those incredibly cheap. A kit with a gasket, solenoid pack, and 2 sensors. And you know, if you go to a shop, they usually hit you for about $300 to swap in 2 sensors out. You know, they don't cost all that much really to do it. Now, this right here is what you're looking at right here. See the wires going into the solenoid? Okay. There's your wires going into the solenoid. Light blue is low reverse control. White's T19 is 2/4 solenoid control. Pink is underdrive solenoid control. And brown is your overdrive control solenoid. That's the way the thing looks. And this is the connector that plugs into it. And so on and so forth. So now you can look at this here. Up here, we can take a little bit closer look at that. See, here's 1, 2, 3, 4, 5, 6, 7, 8. There goes pin numbers. Now, let's see if we can zoom in on that a little bit there, if I can make that happen. Right here. We're zooming in there. All right, we're going to zoom that in. You see what we got there? It's funny to me on that OTC Genesis scan tool we used to use, it would say if it had a low reverse solenoid control code, it would call it left rear. Which somebody, when they typed that, I got some giggling going on over, I don't know what's that about. But anyway, there's your solenoids there. There's your 1, 2, 3, 4. And see, notice this right here, the relay powers that up through 4. See, 4 is the red wire. That relay is going to power it up, and all these solenoids here, these are pressure switch sent. I mean, they got pressure switches in there too, by the way. And sometimes you'll get a code for these, you know, whenever you're doing that. All right, so there's your exploded view of this thing. It's really not that complicated, as you can see. There's not really a whole lot to it. And so, right here, your underdrive clutch is here. Your overdrive and reverse clutch is there. You can see the exploded view of that. Your low reverse clutch is there, and your second and fourth clutch is there. Whenever you've got these parts, when you broke them down and you take them out, you need to pay really close attention to how these parts that have the bushings and all fit together. Jonathan tore one of these down. Actually, the one that went in that Dodge Stratus over there, we tore it down, and he put clutches and seals in it and everything, but it still didn't work right. Well, there was 2 things he did wrong. When he put it back together, the clutches on one of the packs wasn't lined up all the way good, and it sort of bent the clutch disc. And the other thing was the parts were worn out, you know, where you could actually tell those little bushings were worn out, and it was flopping around, and he needed. So anyway, I went up. Gary over there got a whole unit that he sold me for actually less than the hard parts would have cost. So I mean, that particular case, I said, telling Gary, I said, I need this drum and this one. He goes, well, I can get you a whole transmission for what those are going to cost. And so he got me a unit, you know, out of another car. I mean, it was a salvage unit, but that's my go-to guy for transmission parts when I need them. Now, checking the solenoid. The TCM monitors every solenoid circuit by turning off the solenoid to watch for a 42-volt inductive spike. Okay, so it turns it on. This is reading current. Current goes up when voltage goes down. So you got voltage that's coming through the solenoid line. When you pull that down, that solenoid opens, and the current. This is the current, nice steady current here. And when you release it, notice that spike jumps up to 42 volts. And if it sees that, it knows that the integrity of that solenoid is what it ought to be. See that? Because when the magnetic field collapses across those windings, it creates a spike. That's just the way that is. You get a little bit deeper into that. All right. Now, the controller is programmed to keep an ongoing record of each clutch element status during application. This is only on Chryslers now, the ones that you're looking at. They keep up with the fluid volume in each clutch circuit, and it does it on the fly. And the volumes are tracked using hard-written data in the tables in the computer, as well as adaptively learned clutch volume fill numbers. Okay, so see this right here? This is one that we checked here. Okay, this is one of the scan tool, and we pulled up, and we got overdrive with 123, 2.4, underdrive, low reverse. See, these were our numbers here. Basically, it's watching how much it takes to apply that clutch. How much pressure do I have to put in there to get that clutch to apply? If I have to put more pressure in there and record a higher number, it means that maybe the clutch is slipping. Okay, that's what's going on there. Now, A solenoid, a TCM or a PCM compares engine or turbine shaft speed to output shaft speed to determine when or whether a gear is applied. So it's paying attention to these two sensors. It knows how fast this is turning and it knows how fast that ought to be turning. And if it knows what that in this gear, this ought to be turning this, you know, it knows what the ratio should be. It's got little graphs in there inside its little innards. With the torque converter locked at 100%, the turbine shaft spins at exactly the same speed as the engine. And that usually happens only in third and fourth gear. There's a little breakdown of your torque converter there. All right, so there's your cover assembly right there. And there's your impeller. This is actually cut away. This is actually all welded together. And this is actually going to throw it against the turbine, which is hooked into that shaft one in the middle. All right, during this time, it's easier for the PCM to detect a slipping condition. Sometimes it won't know if it's a torque converter clutch or the applied clutches though. All right, so these shells here are welded together. When the converter is fully applied, all this turns in one piece. All right, so, hello. All right, there you go. Now, this piece right here is a stator with a one-way clutch. Now, the thing you're checking with the torque converters, with the tool over there for the plate, you're seeing how much this part moves. You know, because it's got a lining on the back of this that rides against that right there, and as that wears out, you'll have too much slop right here. Of course, most transmission shops just throw a converter at it anyway because it don't cost all that much. All right, so this shell's welded to that one. All this is turning together. Now, inside this shell, you've got something that looks a lot like that. And this is spinning, throwing fluid against that. This redirects the fluid, so it's circling around and around. And this multiplies your torque. Now, I've got a really good video of that I'll show y'all one time sooner or later. So if the output shaft or vehicle speed sensor RPM is 2,000, this is how it knows. Then the algorithm table will apply that RPM figure by the ratio of the gear it knows should be engaged. If it's got third gear engaged, it knows what speed both the input and the output ought to be compared to, right? And, all right, so with slippage or non-application, you might see codes like incorrect gear ratio obtained for whatever gear. See, in other words, it says, I told this thing to go into fourth gear and it didn't do it. Could be a solenoid problem, could be a stuck valve, could be something else. All right, or you might get something like 2-3 shift error. You get me? All right, so assuming the overdrive ratio is 0.696, you multiply that by 2,000, that gives you a proper engine input speed reading of 1392, right? If there's no slip. Okay, so 2,000 times 696 equals 1392, so it's paying attention. If it sees 2,000 there, everything light off, it'll see 1392 right there. Okay, well, if it's slipping, will that number be higher or lower?
Be higher.
Well, this will be spinning faster. I mean, this will be faster in relation to that. You got me? Have you ever driven a manual transmission vehicle that the clutch was slipping in it? You know, you're driving, the clutch is always a straight hookup all the time. You've been in different gears. But when you're giving it gas, when you're crowding the throttle, the tack and this dynamometer ought to go up together.
Yeah,
you get me? But if it's slipping, what's it going to do? The speed won't go up at the same rate that the engine does. You're giving it gas, this clutch is slipping. You see, you'll feel it slipping. And basically, as clutch lining wears out in a manual transmission, the clutch pedal will get higher too. We'll be aware of that. All right, so accepted CVI tolerances on the 41TE. Check the one you're working on for good numbers. Back today, Chrysler published these numbers as acceptable for the 4 clutches. Low reverse will be 35 to 83. 2-4 will be 20 to 77. Overdrive will be 75 to 150. You pull this with your scan tool now, right? And it's real easy to pull it up. Underdrive will be 24 to 7. Now you notice your overdrive 75 to 150. The overdrive in the one that we had was 123. You remember that? It was higher than all the rest of them, but it wasn't out of line because it was within the spec that you'd expect. All right, instantaneous fluid volumes tracked using these clutch fill volumes, and that's for closely spaced shifts or the driver's change of mind, like they're doing this and they let off and they fool with their foot and all that kind of junk. The piston's in here, and it pinches these here fibers and steels together. So the part that's splined on the inside and this drum, when that clutch is applied, this suddenly becomes one with the item that's splined into these clutches. See what I mean? Now a lot of them, whenever you're building these and you're stacking those together, they're basically, you're going to have you wet them with transmission fluid while you're putting them together. Most transmission mechanics won't do that, they'll just throw them together dry, you know, so. But anyway, that's a,
Ms. Rich, and don't those clutches go a certain way? You can't just put those clutches in any kind of way.
well, you actually, in most cases, you just drop them in there, but if you've got too many, when you put that snap ring on the top, you know, like the last piece you put in there is gonna be a nice thick piece, but it depends. I mean, on some transmissions, the little dogs on the outside of them are, you know, wider than others, and you gotta put them in there a certain way. Some of them may just go in anyway. They're not all the same.
My uncle's transmission, I think, I want to say it was Ford Focus that had it. You had to put it in a certain way. You couldn't just drop them in on both sides and work. You had to put it in one way.
Yeah, I mean, I would, yeah, whenever you do, each transmission is a little bit different. Some of them are, you know, but what I'm getting at is, I used to build them on a tailgate of my truck when I was living down in Texas, you know, a long time ago. When people bring a transmission, they wouldn't pull, I'd, you know, jerk it out of there, you know, throw some clutches and seals in it and pop it back together. And Tony, that guy that was over here from Elba, you know, TD, you know, he used to do that. I mean, whenever I taught him to do the transmissions here, and he'd go home, he was doing them at home. And I mean, I think he'd make a pretty good bit of money at home doing transmissions somewhere, on the back of a pickup or in his barn or somewhere. He's doing but I mean, he learned how to do transmissions. He tore a bunch of them apart and put them back together and fixed them here.
Passed away.
Huh?
Passed away a couple of years ago.
Yeah, I remember, I heard about that. It was an accident that he had. There's your early models will lose their learned values if the battery was disconnected. Or the TCM was unplugged. The transmission control module goes to a default setting until the new CVIOs are learned. These are default settings right here. That's what they would go with. All right, late model vehicles and flash updated TCM will remember the CVI values even if the battery's been disconnected. It's non-volatile memory, right? Now, what if you want the TCM to forget them? If you look on your scan tool for a battery disconnect reset, that force erases the CVI value set to the vault values. I have seen these people, you know, sometimes if you've got something that's acting stupid and crazy and won't quite work right in relation to your fuel injection and all that, and you can't really find anything that has failed, it's just not working right, sometimes it just makes sense to go ahead and just do a battery, you know, do a reset. You know, go in your scan tool and just tell it, I want to wipe everything out. Like you did on that other one. You did a reset on that, that little old gal. She had come a few years ago and I did that, and then she wanted to come back. I threw Zach in there, let him ride with her. Of course, he was complaining because he didn't want to ride with the girl, you know, because
I get it.
yeah.
Mess my boy up. I promise you, y'all mess my boy up.
Yeah, she was cute, you know. Okay.
Should've
That's
said more
it
like-
right there. See that? The transmission was slam shifted jumping from second to fourth. This is the one we were just talking about. And when I picked it up on the scan tool, I reset the adaptive value school and fixed the problem. It's like rebooting your computer. You know how sometimes you reboot your computer to straighten it up when it's running slow or not working right or something like that? And so, newer 41 TE controllers got a quick learn procedure that can be selected with the scan tool to update the CVI values after an overhaul or replacement. Okay, this right here, you notice this came out of the book here, replace the transmission control module for the service with the DRV3, perform quick learn and reprogram pinion factor. Pinion factor meaning the transmission control module needs to know what your ring gear and pinion ratio is, because it needs to make decisions based on that. And there's various different ratios on there, you know, usually 3 or 4 to 1, whatever, it'll be in between. All right, the low reverse clutch volume updates during a 2-1 or 3-1 downshift. The 2-4 clutch volume updates during a 1-2 upshift. Isn't that interesting? The overdrive clutch volume update during a 2-3 upshift, and the underdrive clutch volume updates during a 4-3 or a 4-2 downshift. There was this lady that came in here on a GM car one time, and she says, whenever I pull up to a stoplight, it stalls. And I said, well, she must have something on with the idle air control. When I drove it, the torque converter was staying locked. And when you pull up, and just kill it. You know, you crank it up, by that time it done broke loose and you come on back over here. And we weren't doing transmissions that semester, but I mean, I kind of wanted to help her out. So I said, I'll tell you what we'll do. And you ain't got nothing to lose. You know, it's going to cost you a little bit, but it won't be all that much. I said, what we're going to do, I checked the electrical part of it first, see maybe if the wire that was doing the torque converter clutch was maybe shorted to ground or something like that. We checked all that, nothing wrong there. So I said, let's just go ahead and do a service on this thing, and let's pour some seafoam transmission stuff in it. Now, if you're pouring seafoam in one, make sure you're not pouring engine stuff in the transmission. You know what I'm saying? Because they got stuff for engine. But I mean, make sure your transmission tune, because it cleans things off in there. So we've serviced the transmission, poured trans tune in there, and She was good to go. I didn't think I was gonna fix it, but never gave trouble again. That, when you put the transmission in, about 4 years ago, the transmission started cutting up, that Impala. And I did that transmission service and poured seafoam in it, and it fixed that thing for about 3 years before they ever had to come back, and we finally put a transmission in it. But, you know, if you don't have anything to lose, and you explain to the customer, explain how to fix nothing, it ain't gonna hurt anything, let's just give it a try. Years ago, when I was working at a gas station, we had them Chryslers. They were all, sludged up on the inside. We'd take TransClean, and we'd pour in there, and we'd drive the thing around, let the TransClean wash the transmission out, and then we'd change the filter, and then we'd drive it around some more and change the filter again, and a lot of times that'd fix one of them. You know, but most of the time, you ain't gonna have no miracle stuff that you're gonna pour in a transmission. Pour the wrong stuff in there, it ruins the lip seals, and you gotta do it over total overhaul.
I know, I had it's an 07 Ford, Frenza, Super Frenza, and the transmission was slipping, and at the time I didn't really know about it because it was before I came here. But my uncle, he put some of this slip stuff inside the transmission. It still didn't help it, but it was guaranteed that it would help it.
Yeah, sometimes it helps and sometimes it won't. About 50% of the time, you know, you're gonna have some kind of results out of that. That's like putting stop leak in AC systems and all that. It's really a bad idea. Although occasionally you'll fix one using something, you know, something like Blue Devil for head gaskets and all. You know, about 50% of the ones that we use that on, like the one for auxiliary services director, we did on his Toyota truck. He said, let's give that a try. And he stopped having to put water in it after we did that. But then I noticed when it was in here after you put the timing belt all on the other day, that it's leaking antifreeze out from under the rear of the back head, and it's running down the bell housing. You know, and I think after we cleaned all that Blue Devil out, you know, probably we just started to leak or whatever. But anyway, but anyway, low CVI numbers won't cause this, so don't go after those unless the transmission not shifting right. If they're high, they'll go into limp mode. They'll always be in second gear. You know, so that's what limp mode is all about. Here's a Pontiac story. Student calls and tells me her car needs transmission work because it's trying to take off in some other gear except first. I said, check the fuses. Her dad says, he's an idiot. What's fuses got to do with the transmission? She checked the fuses, found one blown, fixed the car. Made him look silly. But I mean, think about it this, what's it going to cost her to check the fuses? You know what I mean? She pulls the fuses, she finds one blown, she puts one in there, she's no worse off. But if somebody says put a transmission in it, you find out it was blown fuse. And I've seen that happen. Yeah, I come over here on a Jeep. He says, I've had this thing in my shop 6 weeks, I can't make it shift. And I pull the transmission control, the CCM harness out from under that right side of the dash and put a 10 amp fuse in there and it shift out perfect. That's all it needed to begin with. He rebuilt the transmission. All right. The Pontiac story is like this. The fuse feeds all the transmission solenoids, okay? And they're operated by the engine control module. If that fuse is blown, all these transmission control solenoids are dead as a hammer. That's why I said check the fuse, okay? Automotive student, my car needs a starter. Me, how do you know? It won't spin over. Get it over here, we'll fix it. So we took off the belt and the car started. The clutch bearing was locked up. We replaced the bearing for $17. No starter needed.
The AC?
The AC bearing, the bearing, you know, that the AC spins on. Well, it's like this piece right here. That's what I'm talking about. See that bearing right there?
Yeah.
That bearing right there was locked up. And that's the one that freewheels whenever your air conditioner's not, or if the compressor's locked up. But that's what was wrong with that one. That little bearing, you get one for $17, and you change it out, of course. And you can't change just this part here without changing the hub too, though, by the way. I'll talk about that next semester. Avoid mistakes. Use common sense and think before you wrench. Right? Know how the system or component works. Check the easy stuff and go after the hard stuff. Don't do the tire rotation until after you finish the oil change. Got that? All right then.
We got it now, don't we?